Welcome viewers, in this video we will see the starter used in the DC motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we will go to the topic. First we will see what is the starter, why we are using the starter in DC motor. Starter is a resistance connected in series with the armature circuit of a motor during the starting period in order to limit the high starting current. So, the starter is nothing but a resistor connected in series with the armature circuit during the starting period in order to limit the high starting current. Now, we will see why we are using the starter, what is the purpose. When a DC motor is started with a full voltage applied across its armature terminal, it draws a more current than the rated value. So, while starting the motor, the armature circuit, it will draw the more current. We will see how it will draw the more current. So, we know that for a motor V, terminal voltage V equal to EB plus IA RA, back EMF plus armature resistance drop. So, that IA can be written as E minus V minus EB divided by RA. So, our aim is to limit the armature current, so that we got the expression for armature current, that is nothing but terminal voltage minus back EMF divided by RA. From this equation, the IA expression for IA is derived. So, since at the instant of the starting the speed is 0, at the beginning the speed is 0. So, the back EMF is also 0, because back EMF is proportional to the speed and torque. So, initially speed is 0 means back EMF is also 0. So, EB equal to 0. So, in this EB is 0. So, only we have V by RA, terminal voltage divided by armature resistance. Back EMF is 0 because speed is 0 at the beginning. So, the armature resistance of a motor is very small value. This RA value is very small, right? In order to limit the current, already the armature resistance value is very small. Now, we will see the one practical example. Let us consider the case of 220 voltage DC motor with the armature resistance of 0.25 ohm. We already said that this armature resistance value is always very less. Here it is 0.25 ohm. Then at the instant of starting, by using this formula, IA equal to V divided by RA. So, we have taken V equal to 220 voltage, RA is 0.25 ohm. So, by 220 divided by 0.25 is nothing but 880 amperes. So, the armature current during the starting is around 880 amperes. This current is much higher than the rated current. This current will flow through the armature winding, mean it will damage the armature winding, right. So, that is the reason why we are using the resistance. Why the armature current is high means, first the speed is 0, so that back EMF is 0. So, IA is only depends upon V by RA. RA value is very less. If we take V equal to 220, it is nearly 880 amperes. So, it will draw around 880 amperes, which is much more higher than the rated current. So, if the current is flowing through the armature circuit, it will damage it. Now, we need to limit this current. But when the motor picks up the speed and the speed increases, the back EMF also increases. So, the armature current IA automatically decreases, gradually come down to the rated value. So, during beginning only it will draw the more current. If the speed gradually increases, EB will increases. So, due to that IA will decreases gradually and it will reaches the rated value. So, only during there is a problem with a high current. So, we need to concentrate while starting we need to limit the armature current. To limit the high starting current, a resistance is connected in series with the armature at the time of starting, only at the starting, and then gradually cut off, gradually reduced as the motor speed increases. So, our main problem is only during the starting it will draw the more current, so that the resistance is connected in series with the armature circuit during the starting, thereby it is gradually reduces. right? So if the resistor is connected in series, what will happen? Now after introducing the starting resistance Rs, Ia equal to V divided by Ra plus Rs. Initially only Ra is there, this value is very less. Now we connected Rs, series resistance, this value is very high. If the denominator is very high, mean automatically the current will be very low, right? So hence the high current is limited. So by introducing the series resistance connected, this value is very much more, it is available in the denominator, so automatically this numerator value is reduces, current is reduces. The starter is also incorporated with protective device to protect from the no voltage and over voltage, right? It also doing to protective, it also act as a protective device in order to protect from no voltage as well as overload. Now we will see the 2-point starter. There are 3 types available: 2-point starter, 3-point starter and 4-point starter. In this video we will see the 2-point starter. So the 2-point starter, the connection diagram is given. So this is the resistance connected in series with the armature circuit. So starting resistance Rs. There are tapping available so that we can increase or decrease the resistance connected to the armature circuit by using the tapping. Now we will see the diagram. So this starter is used for series motor. Series motor means the field winding and armature winding are connected in series. This is the armature armature rotating part. This is the field winding, stationary part. Both are connected in series. This 2-point starter is used in the series motor. So this is the supply, DC supply is given. So switch is available. The double pole single thrown switch. The fuse is available. This is the line. This is the field. So we have 2-point starter. These two are the points available. Line one point refers the line. Another point refers the field winding. So here we have the one starter handle is available. So by moving the starter handle, we can add the resistance to the armature circuit. Here one hold on coil is available. It is nothing but electromagnet. One electromagnet is there, coil is available. So when the current is flowing through this coil, it becomes the electromagnet, it becomes the magnet. So here the needle is available. So this needle can be attracted or repelled by this magnet, right? So this needle can be attracted. So we have series motor, field winding and armature winding is connected. The supply is given through the switch and fuse. Here we have one starter handle is available. On other side, the hold on coil is available. Now see the diagram. The starter handle is not connected, so that this armature resistance are not connected to the motor. So if you connect this, so this is called the off position. This is the start position. If you bring the starter handle in this start position, what will happen? The entire starting resistance is connected to the motor. So the current will be very less. At this point, the entire resistance is connected. The current is flowing through this resistor, so the current is very, very less. If you slowly moving the handle towards in this clockwise direction, what happened? The resistance are decreases, slowly decreases, so that the current will increases gradually. At this point, the resistance is, starting resistance is very, very high, the current is very, very less. So the motor will draw only less amount of current. So that is our aim. The aim of the starter is to limit the starting current. If we slowly reduce the resistance by moving the handle in clockwise direction, the resistance are slowly decreases, so that armature current slowly increases, right? By moving in this position, at this position, it is called a run. So if you put the starter handle at this position, mean it is connected directly without any resistance, right? So it will draw the full load rated current. Now that the current will flowing through this armature and field winding. So at this point, resistance is more, current is very less. While moving the starter handle in clockwise direction, the resistance gradually decreases and current increases gradually. At this point, the current is maximum, rated current will be given, the resistance is almost 0, there is no resistance, it is directly connected, this point is directly connected. This current is flowing through this electromagnet. So this this coil, so that it is electromagnet. So this bar is attracted by this electromagnet. So it will hold this electromagnet will hold this starter handle. This starter handle is attached to this electromagnet, right? So that the starter handle always available at this position, so that the current is rated current is flowing through the armature and field. So now we discussed that the armature current is gradually increases by moving the starter handle, and this starter also used to as a protective device for two different purposes. One is, suppose if the load is very less, the load at this motor is very less, what will happen? The current is we need to protect from two different cases. One is when the load decreases, similarly the supply decreases, no load as well as no voltage. For these two we need to protect from the motor. If the load is decreases, what will happen? The current drawn by the motor also decreases, so that the current flowing through this electromagnet also decreases. So it becomes the demagnetized. If the current decreases, it becomes demagnetized, so that it will release the starter handle. So the starter handle will go to the original position, that is off position. If the load decreases, the current, armature current will decrease. That armature current is flowing through this electromagnet. So if the current flowing through this electromagnet decreases, mean it becomes demagnetized. The starter handle is held by this electromagnet. If the current decreases, it is demagnetized, so that it will release the handle. So it will go to the original position. So the supply is disconnected to the motor if the load decreases. Similarly, if the supply decreases, at the time also same thing, the current drawn by the motor also decrease. Due to low voltage, the current drawn by the motor decreases. If the current decreases, this electromagnet become demagnetized. At the time also this handle is released. So it will release the handle, so that it will go to the original position. So the motor is disconnected from the supply. The starter used for three different purposes. One is adding the resistor, then limit the armature current. Another one, during no load condition, it will this electromagnet become demagnetized and release the starter handle. Similarly, during no voltage condition, at that time also the current is less. Due to the less current, this become the demagnetized and release the starter handle, right? So we will see the description one by one. 2-point starter used for starting DC series motor. It is used for a series motor. L and F are the 2 points of the starter which are connected with the supply and motor terminal. L is connected to the supply, F is connected to the motor terminal. To start the motor, starter handle is moved clockwise from start to run position against the spring tension, right? So this handle is moving in a clockwise direction in order to reduce the resistance and in order to increase the armature current. The starter is to be held in the run position throughout the operation of the motor. So during the running of motor, the starter handle is at the run position. So this is done by means of hold on coil, that is hold on electromagnet. The current is flowing through this, so that it become electromagnet. So it will hold the starter handle. So the starter handle is attracted by the electromagnet throughout the operation of the motor. When the motor is rotating, the starter handle is at the run position. It is held by the electromagnet. Current flowing through the hold on electromagnet magnetize it, and soft iron pieces in starter handle is thereby held by the electromagnet in the run position. When the current is flowing, it become electromagnet, so that the starter handle is held by the electromagnet. Now this hold on coil also act as a no load release. It is also act as a protective device, no load. So during no load, what will happen? When the load on motor reduces, the current flowing through the electromagnet also decreases, and hence the strength of the electromagnet reduces. So the soft iron piece return to the off position, right? So, previously the soft iron piece is held by the electromagnet. Now, the electromagnet strength is decreases due to no load. The current flow is due to no load, current decreases, the strength of the electromagnet also decreases. So, the soft iron piece is released by the electromagnet and it will return to the off position. So that the motor is disconnected from the supply during the no load release. Similarly, the hold on coil acts as a no voltage release. When the voltage is reduces, what will happen? Current also decreases and strength of the electromagnet also decreases. Hence, the soft iron piece is returned to the original position, off position. So that the motor is disconnected from the supply when no voltage occurs. Right. So, in this video we discuss about the what is the starter, why we are using the starter and the operation of a 2-point starter. The starter also used for no voltage as well as no load protective device. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.